Oh, what about ye? Alfa Romeo, Mito. This car's about 2010, 2011, something like that. There's about 80,000 miles on it. We've just done a brake job, pads and discs, and we've had to put an alternator on it. So this video is about doing a couple of quick tests if you suspect your alternator isn't working. So basically, you're not charging. So when this car came to me, wee bit of a backstory, this car actually broke down. The guy was driving along, his dashboard lit up like a Christmas tree, and the car, he basically drained the battery down until the car just shut down. So he had to get towed home. What he did then was he charged the battery up overnight as full as he could, gave me a shout, and I told him, drive it here on a Sunday, someday whenever the roads are fairly clear. During the day, don't have any accessories on whatsoever, and you should make it. And yes, he got here, he drove about 10 or 12 miles, I think it was, and when I came here, the battery was roughly about 12 volts or something like that. Still started, still drove, but the battery was starting to go really down, because the first thing that happens with these cars is the biggest consumer is the electric power steering, so it just shuts it off, and steering goes dead heavy. You can hardly turn it at all, hardly turn the steering wheel. It's really heavy without that assistance. So clearly not charging. Now I have already done the repair. That's the alternator that came out of this car. So I'll give you a shot on that. There's there. So the one that came out of this car is a Denso. So Lancia Fiat Alfa there, and we got a Denso alternator there. Quite keenly priced actually. No surcharge, so I can keep this. And this particular model requires this DAN 993. So if you have, that is the Fiat part number, that 518 number there, and that equates to a DAN 993, which you can get quite reasonably priced. And this came from where we're going to see it. It came from the Netherlands. So this particular system that's in this car, it's quite simple. It's pretty basic actually. So there's only two terminals in the back of it, and yeah. So we'll go through a few basic tests that you want to do before you make the decision. Oh, I need a new alternator. So clearly you put the voltmeter in a battery, the engine running, and if it stays at the battery voltage, doesn't go up, you're looking for about 14 volts. But if it stays about 12 or less even, if the battery's drained, these are a few tests you can do before you can say, right, car needs an alternator. So you can do it in a few minutes. You know what you're doing. This particular system, as I said, it's pretty basic, and it's you don't need any sort of special tools. You don't need an oscilloscope or nothing like that. So first off, what we want to do, this alternator has a clutch pulley on it, so it'll only rotate in the one direction if it's working okay. Right, just have to get a wee screwdriver there. So what I mean by that is, the engine rotates clockwise. So if this clutch pulley has failed, it's possible, now they don't normally fail like this, they don't normally fail where this here can just spin on its own, and the rotor in here does not spin, but it's worthwhile checking, make sure this is actually turning on the belt. Now clearly, obviously you make sure the belt's on, so you make sure that this thing's basically turning, but that could turn. It's quite possible that this bit here could turn and the rotor in there is not turning. So you can do a quick test. You can just jam it and make sure that it's locking in the clockwise position, because the way it's supposed to operate is that it will actually spin anti-clockwise. So the way I describe it to people is it's a bit like the gears on a bike. They allow the bike to freewheel, so you can freewheel down a hill on the bike without turning the pedals, and so it only locks in one direction there. So that's a pretty basic thing, but you could overlook that, change the alternator, and yes, the new alternator will work okay, because this particular new unit came complete with the clutch pulley. And if, however, that it is spinning on its own merit, on its own bat, you can just get a new clutch pulley. You can get that separately, about 20 or 30 quid. And yeah, you do need sort of special tools to put it on. It's multi-splined in there, so you need to hold it. In this case, it's probably a Torx or something. More than likely, it usually is a Torx in there, and there's a multi-splined job there, and you can change that over. However, they don't normally feel like that. The way these things normally feel is they just lock, so it does not spin in reverse on its own. It just it's locked solid. That's the way they normally feel. But anyway, go back to the electrical testing. So we've got two contacts here on this, and we'll have a big one and a small one, and there we can see them marked B plus, B for Bravo, or B for battery. So battery positive, B plus. So this will have the big thick red wire coming from the battery. Well, in this case, in this particular car, it actually comes from the starter motor. So the red wire goes from the battery onto the starter motor and then onto this post here. And then we'll have a D plus, and that's a skinny wire, very, very, very thin indeed. And it is grey and red wire with a wee lug on it there, and it's just held on with a small nut, and it comes from the PCM. Something you might want to look out for on these wee Mitos, I think this is only indicative of the Mitos only, of this sort of era, is this drain, this snaky sort of pipe here. And you can see, and it has like a flat end on it there. So not this fuel pipe here, this big thick pipe. So this is the drain from the scuttle panel. So this allows the rainwater to go down, and it sort of snakes around and then drips down the back of the engine here. So the original Mitos, this drain just went straight down, and it was only a wee thing about that size, and it just clicked in there and just straight down, and that allowed the rainwater to drip directly onto the back of the alternator, and it wrecked the alternator. So this is a modification that whenever the cars went in the dealer, they just changed them over. So this car has the modification okay, but as I said, if yours has just a straight down, and it's only a wee small thing about that size, then you can get these pipes. They're about a tenner. You can buy them there, and off the dealer or whoever, and you just clip that on. So that's a prevention. So here's a wee schematic of that, and your red wire, it's that big thick wire, as I said. It goes onto the starter and then continues on to the alternator. Here it's called the generator, and the generator then is earthed to the engine. And this wire here in reality is only about 12 inches long. It's only about a foot long. So the starter sits here, say, and then the alternator sits there, so it just jumps over, So it's pretty unlikely that you're going to have a problem if the car starts. So you're getting the red wire to the starter motor, and the only thing that you could suspect is maybe the connection from the starter motor to the alternator. So what we're going to do is we're going to do a couple of simple voltage drop tests, and you know, test the earth integrity, test this wire here is okay, and pretty basic simple tests here. We're not going to put any loads on it or anything like that. You should really test this with a load on it, but we'll just do a quick voltage drop test. This is just quick and dirty testing. And then the other one is this control wire, which comes from the powertrain control module, or the ECU, or whatever you want to call it. And we can see there, generator field control. So that's the skinny wire, the grey and red there, that goes on to the D plus terminal. So when this car came to me, the battery was reading about 12 volts, something like that. It's pretty low, because the guy drove it basically on battery power only. So there was no charging taking place, so it had drained the battery, you know. So the new alternator is fitted in this car, and I had it running for about 5 minutes, and it's brought the battery voltage up to near enough 12.5 volts, which is where we would want it to be. And it was outputting about 14.4 volts, which is fantastic with the engine running. So clearly the engine's not running. And I'm just showing that I'm using this, this is just using this as a voltmeter here. You could use any voltmeter. Just using this for the big screen here. So a quick voltage drop test on your earth. If we take that off, put it onto a decent earth, and we see it's basically practically nothing. So if you have an auto ranging voltmeter, you know, so we're measuring sort of millivolts here, you know, so whenever you're not connected, you'll see it jumping about there a wee bit, and then you'll know you're connected, okay, because it'll stabilize it. So quick test there, that's fine. I've extended with this blue wire, so that's clipped on to the back of the alternator on the B plus, so that's the big stud with the big thick red cable, and we can see it's reading 12.47 volts between B plus on the alternator and ground in the battery. And we can just test the battery to see if that's correct. 12.47, so that's the same, so that looks pretty good. We'll go back onto that again, and what we're going to do is we're going to swap our negative on the voltmeter, on the multimeter, and we can see if there's any voltage difference. So we'll just take that down. So we're reading in millivolts here. If you have an auto ranging meter, you don't need to do that. So you'll know you're on there. If you're not on, again, if you're not on, it's bouncing all over the place. We'll put it on, and we'll get practically nothing. So what we've done there then is we've done a voltage drop test on this red wire, and from battery negative to ground on the engine block. So that rules all that out. Now, some people might say, you really need to load test that. I have seen it on a few weeks ago on a Peugeot, I think it was, where this connection was just a back-to-back connection on the starter motor, and that connection was bad, and that's why he wasn't getting a charge back up to the battery again. So that connection can be bad. In this case, in these cars, it's not like two lugs back to back. It's, you know, a crimp connection. So I wouldn't have thought that that would give us any trouble anyway in this particular setup. But nevertheless, we'll go on to testing this wee signal wire here from the powertrain control module to the alternator. Before we go to the car, just to elaborate on that Peugeot case study, it might just clarify this a wee bit better. So I said that we had a bad connection here, and that's because the lugs on the post of the starter motor were back to back. Now, what I found out after the guy had picked the car up and I discovered what the problem was that he had replaced the starter motor himself. So if he had told me that at the start, but anyway, this is what you have to put up with. But anywho, the simple voltage drop test, you know, just showed that up in seconds, because in his case, the alternator was indeed charging. So we were getting 14 volts here, but we were only getting 12 volts at the battery. So he had not made a good connection at the post of the starter motor. However, in this case of this Alfa Romeo, this wire is, you know, like a through wire. It's one piece of cable that goes along, and then there's a C-crimp on it with a lug which connects onto the starter post. So that is actually one piece of wire. In the other example that I was saying about the Peugeot, there were two separate pieces of wire, and this was the connection that was joining the two together. So with a voltage drop test on the Peugeot, then we had 2 volts, at least 2 volts of a difference between there, and that showed the problem up right away. So what the voltmeter is actually doing is it's measuring the difference across the battery here. If you put it across the battery, so your neutral or negative is 0. So say you have 12 volts on the positive side, so the difference in potential there is 0 from 12, so you get 12 volts. So in the case of our Peugeot case study, clearly the alternator was spinning and it was producing 14 volts at this point. Our difference in potential between this point and this point is 12 here and 14 there, so it's 2. Now we could also say that because the alternator was indeed producing an output, then it was indeed, this wire was under load, and because it had a bad connection here, that then broke down under load. So the connection broke down when loaded, and so we saw the potential difference of 2. So that's what your voltmeter is actually doing. Do the small wire. I'll just show you with the power probe, and this is the way I actually tested this. So if I test the B+, I'm showing 12.3 volts there. So with the tip clear there, because I'm going to energize the tip now, and press the button, it's 12.3. So I know it's the same voltage here as it is at the battery. So that saves me from getting anything out. So this power probe here, or power scope is called, this one, is directly connected to the battery, plus and minus. So the wee blue clip up there at the top is on the D+, and if I touch it without pressing the button, whatever you do, don't press the button, we get battery ground. So that's with the key off, the key out. We can see there's battery ground there as well on the aircon pipe. So this particular model with the aircon, if you're going to do an Alfa Mito aircon, you need to basically take the air compressor out, the air conditioning compressor out, and release these pipes and stuff, and let all the gas out and all that. And you do that in a controlled manner, because it'll probably be sitting about 50 psi. With the ignition on, then if we do that test again on the D+, that's a small wire, we can see it's still battery negative. So we'll start the car. So the engine running. This is a good alternator. This is a known good. So we're 14.2 volts at the alternator, so the voltage is increased, so this alternator is charging. But if I look at our command wire, we can get it on. You can see that it's 13.4 volts. That's better. So that's coming from the engine computer. So it's just a wee bit less than battery voltage, because it's going through the resistors and stuff like that in the engine computer. So that is a known good. So we now have the D+ disconnected, and so we're going to test the output of the PCM here, just whenever we turn the ignition on. So at the minute the key is off and we're getting nothing. So with it disconnected off the D+ terminal, we do not get battery negative anymore, we just get 0. So we'll just turn the key on, and we're still connected with the blue wire there to that PCM output D+ wire. That's ignition on. So we get just slightly less than battery voltage. So if the alternator control wire reconnected to the back of the alternator on the D+, so that's the small wire. So with the ignition off, we see battery negative. We're going to turn the ignition on. That's ignition on. Still battery negative. And we start the car. We get slightly less than the charging voltage there. So if I have a look at this signal from the PCM, we can see there's no duty cycle, there's no frequency, it's just a straight voltage on this particular system. So with this new alternator fitted here, and I start the engine, that's what we're expecting to see there with respect to charging voltage. So yeah, so this one's a fix anyway. New alternator, wee bit of quick testing with that wee power probe there. I done that testing in a few minutes just to check the wires there, and was able to call an alternator pretty quick. So that's it for this one. Maybe you get something out of it. Many thanks for watching as ever, and